All right, good day, everybody, and welcome to Statistics 4. This one is going to be a short video on measures of tendency, but for grouped data. Now, in terms of measures of tendency, mean, median, and mode, we usually look at raw data, and we also looked at ungrouped data. And just as a review here, we saw that we have some ungrouped data. So we have marks out of 10, right? And we have the students and the frequency of students who got between 0 and 10, yeah? And in order to find the mean from a frequency distribution, this data is ungrouped. So I have individual marks here. It have no intervals, no groupings, right? So in order to find the mean from a frequency distribution, ungrouped data, we had to use this formula. Now this formula, remember, x with the line above it means mean, that represents the mean. The summation is adding up, right? So we adding up all of what? We taking the frequency and we multiplying it by each one of these values here, right? So these are the two things on the frequency distribution. You have the frequency here, and you have whatever in this case is marks out of 10, yeah? So we're taking each one of the frequencies and we're multiplying it. So what I have here in this third table is the frequency multiply by the mark, f times x, right? So this is frequency 2 times the mark 0, and that gives me 0, right? This frequency 5 times the mark 1 gives me 5, yeah? Now, if we remember in our stats 2 and 3 videos, we pretty much went over this process in detail, and this is just a quick review. So once we multiply each one of these frequencies by the mark, 8 times 2 is 16, right? We find the summation of them. So we add them all up. And then we divide that by the summation of our frequencies. So we just add up all of the frequencies here, right? And you know that should give us our total cumulative frequency, which is really n, you know? So so this is kind of equal to the summation of f multiplied by x all over n, which is the total number of students, right? Which is what you will get when you sum the frequencies. So when I find my summation of fx, right, what I'll do is I'll add all of these up. So the summation of fx is going to be equal to what? Let's check it out. And that gives me 494. And now let's just find the summation of f, which is the total number of students, and we will get that to be 100 students total. So now we go 494 divided by 100, and that gives us 4.94. right? So the mean, in this case, the mean mark out of 10, the average mark, when you want to ask the question, well, what is the average mark that students got? Out of 100 students, the average mark was 4.94, pretty much almost 5, right in the middle of the distribution right there. So this was just a review of how to find it from ungrouped data. But now we have to take a look at grouped data. So we have a frequency distribution here, and let's just look at these two columns over here. We have marks out of 100. Now it makes no sense having 100 data points listed out. That's just a lot to deal with. So instead we will have it in intervals, right? All of the students that got between 1 and 10 marks, well, 1 student, right? How many students got between 41 and 50 marks? Well, we saw 25 students, right? So what we need to do is we need to find the mean, and we have grouped data this time, right? Now, essentially, the mean is pretty similar to what we did before. We have the summation of the frequency times x, x being the mark in this case, over the summation of the frequency, and we know the summation of the frequency is the total number of students, right? So we can see that not much has changed, but the problem is this mark, because if we look to multiply the frequency by the mark, let's try it. The frequency 1 multiplied by what? You know, I have an interval here between 1 and 10. So what am I going to do in this case? So in this case, instead of multiplying by the interval, what we are going to do is multiply by the midpoint of the interval. So on this side of the table here, you could see that I have, on this column, I have all of my class midpoints. So the midpoint 1 to 10, the midpoint is 5.5. The midpoint of 11 to 20, that midpoint is 15.5. The midpoint for 21 to 30, that midpoint is 25.5. So now that I have my class midpoints, I will multiply this frequency by each midpoint. And that's what I have on this side of the table. Frequency multiplied by midpoint. We could see 1 times 5.5 gives us 5.5. 7 times 15.5 gives us 108.5. So once we find all of that, well, now we could add up. We have here f of fx, f times x. So now we could find the summation of f times x. And if we add all of these up together, what will we get? 4,820. And we see here that the summation of the students, the summation of f, which is the same as n, if we add these up together, we will get 100 students. So now we could find our mean, and the mean will end up being 4820 divided by 100. 48.2 is the average mark here in this class of 100 students, right? So in terms of finding the mean from grouped data, when we have intervals, you just find the class midpoint for each interval, and you multiply your frequency by that, and you just apply your formula, and you're good to go, right? Now, in terms of finding the median, and we'll just do a review of ungrouped data, and this will just be a really quick review. You could check out the Stats 2 video for more details. So we see here that we have ungrouped data. We have masses 51 going straight up to 60, right? And we have the masses of students. So this frequency distribution here is of students, yeah? So now we have the position of the median, Q2, which is the guy who is supposed to be smack in the middle. What is the median mass of students, right? Well, you know, we have this formula here, and this formula gives us a rank. But in order to do this, we have to rank the students. Right now, the students are in a normal frequency distribution. So for finding the median, we first have to find the cumulative frequency. So finding the cumulative frequency puts the students in a rank from 1 to 100. So now we could kind of find where the student is in this ranking here. So what we do is we find n to be 100, and we got 100 from this last value here, 100 plus 1. So Q2 is a half of 101, which is 50.5. So we know that is the 50.5th student, right? You can't have a 50 and a half student. So it has to be between this mass here that we're looking for has to be between the 50th student and the 51st student. So we go in here, and this is where we look in our ranking. We see that the 50th student is going to be in this 55 kilogram region, but the 51st student will be in this region, the 56 kilogram region. So in order to find the true median, we now have to add these two together, divided by 2, and what we will get is 55.5. However, for grouped data, it's a little bit different, right? For grouped data, we could see that we have marks out of 100, and just like before, we separated them into groupings or intervals, right? Now, if we just simply say that the position of the median is a half n, we don't have to do n plus 1 because if we had Q2 as a half n plus 1, if n is a really big number, n is a huge number, that means that this plus 1 isn't really gonna make that much of a difference. So we don't have to even worry about this plus 1, especially if n is a huge number. So we'll just say it's a half n, right? So the position of our median is a half n, the half nth term. So in this case, n is 100. So therefore, we will have Q2 being a half of 100, which is 50. So the 50th student, right? Now, if we look at our cumulative frequency curve here, we could see that the 50th student falls in this bracket, less than 50, which kind of falls in this interval. So Q2, at least we could see that it's in this interval here, right? 41 to 50. However, we can't really find the exact median just yet. Usually, to find the median of grouped data, we have to draw a cumulative frequency curve. So we take our cumulative frequency, which will be on the y-axis. All right, remember, frequency always goes on the y-axis, but in this case, it's the cumulative frequency. And we have our marks out of 100, and we can see the cumulative frequency here is also out of 100, right? And we'll have 0 here. And so we draw our cumulative frequency curve. It's not going to come out like a normal frequency distribution, like the normal curve like this. This is a cumulative frequency curve. So there is a difference, right? Don't mix them up. So the cumulative frequency curve would end up looking something like this. We would see here that we have cumulative frequency on our y-axis out of 100. We have the marks out of 100 on the x-axis, and we plot each point 1, 10, 8, 20, and it's best to do this on a grid. Usually a question that will require you to find the median from grouped data, the question itself would probably ask you to find your cumulative frequency curve first. So once you draw the cumulative frequency curve, well now, and it's best to draw this on a grid, on an actual graph paper grid, and measure out all of these guys, make sure they're evenly distributed, right? So now we could actually read off what the median is. So we could see here that the nth term is the 50th term. So from the 50th term, we just go right across until we cut the curve, and then we go down vertically to meet the point here. We could see that our median is around 49. So we could get a value, estimated value of the median from a graph. And just remember to make sure that you use graph paper and draw your graph. Be very careful about the intervals here. Make sure that they are very even, so that you can easily read an answer, right? So in terms of the mode, when we were dealing with ungrouped data, the mode was definitely the easiest thing to find. We had the mode here of ungrouped data, which is the number of children in a family, right? And the mode, we have the frequency of families here. And the mode is just the one with the largest frequency, right? So we have 10 families here who actually had 5 kids in the family. So the highest frequency is your mode, right? This is when we're dealing with ungrouped data. When we're dealing with grouped data, it's a little bit different. Here we have the mass of students, right? From 50 to 109 kilograms. And we have them in intervals. So we are dealing with grouped data. And we have the frequency of students here. So we can see the largest modal class, right? We could read the largest frequency here, 35. We could see that largest frequency of students here way in this class, the 70 to the 79 class, right? So this here is called the modal class, and that is the class where the mode exists in. So now we need to find out, well, what is the mode exactly? It's somewhere in here. It could be 71, it could be 72 or 75. So how do we do that? Well, we actually have to construct a frequency histogram. Right? Now remember, when we did histograms, please make sure that each one of these bars here are of an equal width, right? Especially pertaining to your class boundaries. So you can see here that this lower boundary is 49.5. This upper boundary is 59.5. This lower boundary is 59.5. So I have this 59 being the boundary of these two classes. We could see it here. The 59.5 being the boundary of these two classes. So when you're doing your histogram, please ensure that you use your class boundaries. The bars should be right up against each other, and the width of each of the bars should be equal or proportionate to the width of your class interval. Now, how do we find the mode from a histogram? It's kind of a tricky process, actually. What we actually have to do here is we have to look at the histogram. We could see here that this is the highest frequency, and this here is our class, the modal class, right? The highest frequency tells us that the mode is taking place somewhere inside of this class between 69.5 and 79.5. Yeah, the mode is somewhere in here. So how do we find the mode? Well, we had to do a little bit of funny business. We have to look at the class before it, and we have to look at the class after it. So the modal class, we're looking at the modal class, we're looking at the class before and the class after, right? And in the class before, we're looking at this point over here, and we're going to take a line from this boundary, this point, and we're going to draw it up to this point over here, right? So we have that line going on. Then we look at this class after, the upper class, from this upper boundary here. Right? And from the upper boundary, from this point, we will draw a line connecting this side of the modal class here. Right? And where those two lines intersect, we could now draw a vertical line downwards. And remember, we are drawing our histogram on graph paper, so we can actually read out that mark here, and we could see that the mode from our graph would approximate to around 72 kilograms. Right? So this is how we find the mode from grouped data. You have to draw your histogram, and usually the question would ask you to draw the histogram first, and then they would ask you to find the mode from the histogram. And this is how you find the mode from a histogram. right? Especially when you're dealing with grouped data. So that was it for Statistics 4. It's a nice short video here, and we are dealing with the measures of tendency for grouped data. Look out for Statistics 5, where we'll be dealing with the exciting topic of probability.